about nesting structures. At this point, we've learned about 7 different types. The 5 primitive types so far are integer, float, boolean, string, and none. The 2 composite types we've seen so far are lists and dictionaries. These 2 new composite types are special because they are composed of other types. There are more composite types that we will learn about before all is said and done. In fact, there are even ways to create entirely new primitive and composite types. But for now, we'll stick to these basic 7 types. With lists, we learned that composite types had subtypes. For example, you could have a list of integers. Dictionaries have multiple subtypes, one for each key and one for each value. For example, you could have a dictionary that maps string keys to float values. You can also use composite types as subtypes. In other words, you can have lists of dictionaries, or dictionaries of lists, or even lists of lists. There are no practical limits to how many times you can nest composite types. Let us look at a concrete example. Shown here is a list of dictionaries. Each dictionary is being used as a record with the same keys. These dictionaries can therefore represent a bunch of animals. The subtype of the list is dictionary. The keys of those dictionaries are all strings, and the values are either strings, integers, or Boolean values. To quickly understand the structure of a complex nested structure, we find it useful to model it. In the diagram below, we see that we have a list of dictionaries, where the named keys map to the different types. As you process this complex nested data's structure, you have to stay aware of where you are. This is similar to needing to navigate a maze. Consider a list of dictionaries like the one shown before. If we wanted to print the name of each animal, we would first need to process them as a list using a for loop. Then we can process the individual dictionaries. Here we see a dictionary that is composed of dictionaries. When we access these nested dictionaries, we use square brackets chained together. The expression on the bottom accesses an element of the dictionary. Nesting dictionaries is an excellent way to cluster related information. As previously mentioned, there are no limits to how much nesting can happen. Here on the left, we see a list of dictionaries that represents an event calendar. Instead of processing this list with a for loop, we can chain list indexing and dictionary access to look up specific elements. As our nested structures grow more complex, it becomes more and more important to understand the nature of the data to learn to navigate it.